origin and evolution of Earth's crust. This is the first topic in your syllabus. Remember, this is different from origin and evolution of Earth. These are two different things. Okay, this is about the crust, as in how are the oceans formed, how are the continent formed, and this is about the Earth itself. You remember the theories of Earth's origin? So we have planetesimal theory, we have the tidal hypothesis, we have the supernova theory, we have the Big Bang hypothesis, okay, we have interstellar dust hypothesis. Okay? So these are not same things. This is, many of the students I have seen, when they are discussing this, they end up talking about this. You have the nebular hypothesis. We have nebular hypothesis. Okay? So this is not what the topic is asking us. The topic is asking us, what is the origin and evolution of Earth's crust? Okay? So let's start off now. The first point is that Earth's crust is differentiated into oceans and continents. So I think you know the property of the oceans and the continents. The oceans are basaltic, the oceans are basic, oceans are dense, oceans are mafic, oceans are thinner. They are thinner, 1 to 3 kilometers. The oceans are denser, 3.5 is density. Continents, on the other hand, these are granitic, these are andesitic, these are mostly acidic and intermediate. Okay, these are less dense, about 2.5 density. These are felsic and intermediate, and these are thicker approximately, okay, 60 kilometers in parts. In some areas can also be about 80 kilometers thick. Okay, yes, this is non-ferromagnesium silicates, and these are mostly ferromagnesium silicates. The Earth's surface is differentiated into oceans and continents. This is the first point. The second point is origin of Earth's crust is related to the origin of Earth itself. इसमें कोई doubt नहीं है. Okay, how was the crust formed? The crust was formed, okay, in some process where the whole Earth was formed. It is related to the origin of the Earth itself. Okay, but 3.84 billion years ago, the nature of the crust must have been very different. Okay, what we have today, that is not what the crust was 3.8 to 4 billion years ago. The nature must have been different. The differentiation of the crust must have happened later. The differentiation of the crust, it became part oceans, part continents, must have happened later by some other process. So 3.84 billion years ago, the nature of the crust must have been very different. So the next point is the initial crust may have been the outermost nebula layer that must have cooled and solidified. Okay, the outermost layer कैसा होगा? The outermost layer must have formed from the ancient nebula. The nebula was cooling, the nebula was contracting, and the nebula became solid. Such an initial crust must have been very brittle and unstable. सबसे पहला layer बना. This was the nebula that we have. The nebula starts to cool, and a very thin outermost layer must have formed. A very brittle layer, and inside is still very, very hot. Okay, and this is the initial layer, much different from what we have today. much different from what we have today. So such initial crust must have been very brittle and unstable. Unstable because very, very hot inside. आराम से टूट जाएगा. It must have been unstable. आराम से टूट जाएगा, deform हो जाएगा. It's a very thin layer it has formed. Okay. Next point here is this initial crust must have been subjected volcanic eruptions and repeated fracture because of meteorite impact in absence of an atmosphere. Okay, this initial crust, okay, must have been subjected to volcanic eruptions. It's not a stable one. Okay, and must have been repeatedly fractured. It must have broken repeatedly because of meteorite impact in the absence of an atmosphere. So think of this. So I have this initial crust, a very, very thin layer, a brittle layer, an unstable layer. Okay, and inside it is very, very hot, and Earth has no atmosphere. So lot of impact of meteorite striking, lot of, God knows how many millions and millions of meteorites must have been striking. And because of striking, this crust must have cracked. Because it's a brittle crust, a very, very thin brittle crust. This must have cracked. And for every crack, because hot inside, lava must have come out. Okay. And this lava coming out will start off series of convection cells here. Okay. So this initial crust must have been subjected to volcanic eruptions and repeated fractures because of the meteorite impact in the absence of an atmosphere. Okay. The magmatic eruptions and the disruptions must have set up mantle convection cells and volcanic outflows. Make sense? ये जो disruptions हुआ है, so the magmatic eruptions and the disruptions must have set up mantle convection cells and volcanic outflow. Is it okay? So I have this thin outer layer. There is the impact of meteorite, and this impact would crack the crust, and the mantle cells would get set up because of disruptions. The mantle cells would set up because of disruptions. Okay, so every crack, some lava comes out, and there is circulations inside the mantle. It's like disturbance. These are the mantle convection cells because of impact and fracture of the crust above. It's like ripples inside, you can think of. There's a lot of there's the impact, and the molten magma starts circulating. The impact of the meteorite, the impact will crack the crust, release of pressure, some lava comes out, and the remaining amount of magma will start to circulate. Yes, inside is still very hot because नया earth बना है ना, नया earth बना है, so inside is not entirely cold. अभी भी earth has not completely cooled, right? It is not completely cooled. So understand, it's all a part of how we are hypothesizing what it must have happened. Impact and fracture of the crust above. Mantle convection because of impact and fracture of the crust above. Okay. Why impact of meteorite? Because there is no atmosphere, Ritvik. Okay. Are you aware that Earth is continuously bombarded? What does the atmosphere do? The atmosphere burns the meteorites. Agar atmosphere nahi hoga, all of it will strike the Earth in absence of atmosphere. ठीक है? Next, continue. The convection cells would have forced the initial lava eruptions and the first igneous rocks back into the mantle for repeated partial melting. the convection cells would have forced the initial lava eruptions and the first igneous rocks get pulled back into the mantle, okay, for repeated partial melting. For repeated partial melting. Okay, so it's something like this. So what's happening is, this is the crust. This is the initial crust. And some impact here, there is the crack, lava comes out, and maybe some igneous rock is formed here. And remember, underneath this is the convection cell. Because of this igneous rock will move and get pulled back inside. Partial melting, again come out, again gets pulled back inside. Partial melting, again comes out, again becomes solid, again gets pulled back inside. Okay, pulled back because of convection cells. The convection cells will drag it back. Okay, so something is diverging out and pulling inside. This rock will move here, and then get pulled inside. Okay, this rock will break, will move here, and again get pulled inside. How is the ocean getting subducted? Okay, so the convection cells would have forced the initial lava eruptions and the first igneous rocks back into the mantle for repeated partial melting. So in the partial melting, what will happen? Okay, what will happen is the very, very ultramafic rocks will convert into what? So if we had very, very, very ultramafic rocks, partial melting will give us very, very ultramafic. Partial melting will give us ultramafic. Partial melting will give us the first mafic. The first mafic is the basalt. समझ में आया? बार think of how we remove ghee from your curd. Bar you are churning. You churn continuously. Okay. So very, very mafic will become very, very mafic, will become ultra mafic, will become mafic, and the first basalt. उसके बाद क्या होगा? This first basalt, this is how the first ocean crust must have formed. Make sense? अभी पहले स्टेज में ही है. Okay, the first ocean crust कैसे form हुआ होगा? Repeated partial melting. अच्छा, once the ocean is formed, okay, will we have subduction again or not? So point number 7. Okay, the first or the initial ocean crust is a further forced to subduction, is further forced subduction and partial melting to re-emerge as the first continental crust. So now what happens? Basaltic rocks, it undergoes partial melting to form the first andesite and the granitic rocks. The first initial ocean crust is further forced to subduct and partial melting to re-emerge as the first continental crust. So this is part of the idea called as partial melting. Okay, the first ocean will undergo partial melting to form the continental crust. Now tell me, these continents, these first continents are very small and are called microcontinents. The first continents, the small continents, and they are called as microcontinents. Yes, Sangam, correct. All the crust initially was basaltic. This is what we mean by crustal differentiation. Okay, so this explains, ये जो process है, this explains, okay, the crustal differentiation, continents from the oceans. This is called as crustal differentiation. The continents are differentiated, continents are separated, continents form from the oceans. Something like what's happening at, okay, something like what happens at OC margins. Something like what happens at the OC margins. So these are the beginnings of the first continents called as microcontinents. The beginnings of the first continents called as microcontinents. Now the point, the catch here is microcontinents once formed will move on the Earth's surface and drift because of the convection currents, but will resist subduction. Make sense? The microcontinents once formed. एक बार बन गया microcontinent. These microcontinents will keep on moving on the surface. They will keep on moving on the surface. And continents will resist subduction. Will continents subduct? Why will continents not subduct? Why? Because continents are lighter. Continents are buoyant. Continents are less dense. It's like the ping pong ball. It will not go inside the mantle anymore. So continents once formed, they will not subduct. Okay. So by this logic, which came first? Okay. Therefore, this means oceans are more fundamental. Oceans formed first. Continents formed from ocean crust differentiation. Is this point fine? Oceans are more fundamental. Okay, oceans are formed. Okay, from the oceans form the continents. Okay, the continents are formed from the ocean crust differentiation. But do you understand this? That oceans can be destroyed. Oceans can subduct. Oceans can be destroyed. Oceans are more fundamental, but oceans can be destroyed. Oceans can subduct. But whereas continents are forever. Continents can move, they can collide, they can fuse, they can break up. But continents cannot be forced into the mantle and destroyed. Does this make sense? Oceans can be destroyed. Oceans can subduct. But continents, they can move. Continents can collide. Continents can fuse. Continents can break. But continents cannot be forced into the mantle and destroyed. Okay. So today, the oceans are getting destroyed and recycled as continents. And continents keep growing and adding on the surface. Okay. Now, an important point here. This has been also established in ocean mapping, and on Earth, nowhere is the ocean older than the Mesozoic times. This has been established in ocean mapping. Ocean mapping में established हो चुका है that on Earth nowhere is the ocean older than the Mesozoic times. Okay, why? Which is more fundamental? Oceans or continents? Which is more fundamental? Oceans. But on the Earth, what type of older rocks we have? The older rocks are ocean rocks, or are the older rocks continent rocks? Which are the older rocks? Continents are older rocks. Why? If oceans are more fundamental, then why are the continents older? Because the old ocean has been destroyed. Okay, the old ocean has been subducted. Like in your house, who is older? Your great grandfather is older, or are you older? The great grandfather is older, but he is not in a house. Why? He has expired. तो आज के डेट में आपके फैमिली में है नहीं. Why? Because you survive and not your great grandfather. They don't balance. This is the challenge of tectonics. They actually don't balance. And we do not know how Earth is maintaining its constant surface area. Okay? This was the criticism we wrote under tectonics. Remember that we do not know how exactly the balance is happening. Don't underestimate the power of the ocean crust. Okay, but the more fundamental is don't underestimate the power of the mantle currents. Convergent boundary is less. Okay, that's why the oceans are adding, but the old oceans are getting destroyed. We are adding oceans, but the old oceans are getting destroyed. As of now, ocean is not older. This was discovered and established by Harry Hess. It was discovered and established by Harry Hess. This is one of the evidences of tectonics. Okay? This is the microplate tectonics theory. Today the oceans are getting destroyed and recycled as continents, and continents keep growing and adding on the Earth's surface. Now this was discovered and established by Harry Hess. Nowhere is the ocean older than the Mesozoic times. Nowhere is the ocean older than the Mesozoic times. So microcontinents in time, the macrocontinents have collided and fused to become bigger and form supercontinents. Such supercontinents break up, drift. Such supercontinents, they break up, they drift and collide and fuse again. They collide and fuse again to form newer and larger supercontinents. In time, microcontinents have collided and fused to become bigger and form supercontinents. Such supercontinents break up, they drift, they collide again and fuse to form newer and larger supercontinents. We have traced, we have the following supercontinents to Earth's geological history. We have traced the following supercontinents through Earth's geological history. Valbara supercontinent, Ur supercontinent, Kenor land supercontinent, Atlantica supercontinent, Arctica supercontinent. These supercontinents, these are older than 2.5 billion years. Write some names. Valbara supercontinent, Kenor land. This is Valbara supercontinent, Ur supercontinent, Kenor land supercontinent, Atlantica supercontinent, Arctica supercontinent. Some of the names of supercontinents. Arctica supercontinent, and we have some more of them. We have a Nuna supercontinent, also called Columbia or Hudson land supercontinent. We have Pannotia supercontinent, Rodinia supercontinent. So this Nuna supercontinent, this was approximately 1.9 billion years ago. The Nuna the Nuna supercontinent was approximately 1.9 billion years ago. Rodinia supercontinent was approximately 500 to 700 million years ago, and 8 is Pangaea approximately around 300 400 million years ago. You have some names of the old ancient supercontinents because they're very large. जो हम Pangea का बात करते हैं, this one, this is Wegener's supercontinent, 300-400 million years ago. So remember, Wegener could not explain what happened before Pangea. Now we have an example. The size has increased, and in the future, again, we'll have another supercontinent. ये वापस जुड़ेगा, and we'll have a new supercontinent. In fact, in part of Karnataka, we have found rocks that belong to the Ur supercontinent. Karnataka के पास में, okay, it is there. Pangea 1, Pangea 2, okay, is essentially, this is Pangea 1, Pangea 2, and we have subsequent ones. अब आप लिख लेंगे, how was, okay, Earth's origin. So now tectonics can explain, okay, ये जो part है, this is part of the microplate tectonics.